My name is Matthias Zenger. I'm a software engineer in our Zurich office, and I'm working there with a couple of engineers on Google Base related projects. And one of the products we developed is an API for Google Base. And yeah, but before coming to the API, I quickly want to explain what Google Base is. So as I said already, it's a platform for applications dealing with structured data. And you can think of it as a service that allows you to store, share, publish, and also search, of course, structured data. The main user-facing components that you can see that we provide is a front end that allows you to search all kinds of content in Base. Then we have an application for providers. It's a dashboard, basically, that shows you all the content you have in Base. You can edit data items. You can delete them. You can turn them into draft form. It basically allows you to manage your content in Base. The other component is a feed upload service. So if you want to give us a lot of data, and you don't mind that this is processed asynchronously, maybe later, a day later, then you can upload a feed of content to one of our FTP servers, and we will pick it up and process the data and enter it into Google Base. And the last component is the API. This is what the talk is about. This one is mostly for application developers that want to access content in Base programmatically. Before we look at the API in more detail, I'd like to quickly explain the data model of Base. So you can think of Base as a repository of data items, where a data item is basically owned by a single user. We call this the content provider. And this is typically the person who uploaded the content. But every item that you upload into Base is accessible by all the other users. So everyone can see it. So it's a kind of a publishing mechanism. A data item itself consists of a set of attributes, where an attribute is a name-value binding, basically, which is typed. The types that we're currently supporting are integers, floating point numbers, booleans, text, URLs, dates and date ranges, and locations. So we need a way to classify items so that we have to give them a semantic. And we have a very coarse-grained way of doing this by asking every content provider to classify his item according to an item type. An item type is, from Google, we are basically proposing a couple of item types that we're using in our applications by telling our content providers the attributes that we expect to see, what types they have, and sometimes also popular values. But you're free to define your own item types, so you can use whatever item type you want. So here's an illustration of the data model. I don't want to go into details. This is just to show you how simple the model is, but it's very generic, so you can use it in a lot of different contexts for different set of purposes. So let's look at some examples first that are illustrating these concepts and the visual user-facing components of Base. As a first example, let's see how we can use Base as a means to share recipes. Recipes is one of the cases, one of the item types that Google proposes. So for the item type recipes, we are listing a number of attributes that we expect to see in recipes. So there's a title, a description, there's an attribute cuisine, course, main ingredient. They're all of type text. Here's some example values that you can use, but you can, of course, enter whatever value you want to enter. And here's some other attributes of a different type. So there's a servings count of type integer, calories of type float, cooking time of type integer with a unit in minutes. So how would I enter an item that is conforming to that type? So this is where you can use this provider-facing web application that I was mentioning. So you can go to your dashboard. You can say you want to enter a new item. We ask you for the item type. You say recipes. You'll get back a screen like this, which has already a list of the attributes that we're proposing. You can enter values. You can add new attributes if you want. You can also remove existing ones if you don't have content for them. And then you just press publish, and we'll index your content immediately. And it's searchable usually within a minute or so worldwide. Now, if you want to see that you can actually find it, you would go to the search box of Google Base. It's the search application I was mentioning. It looks a little bit like this. You can enter keywords, and here this is a big difference compared to web search. You have these pull-down menus labeled with the with some attribute names. So these allow you basically to search in a more structured form. So you can constrain the value of the cuisine attribute or main ingredients or course attribute by looking at that pull-down menu, and then you will get more specific results. So in this case, I entered chocolate mousse as the keywords, and I get back a few results, chocolate mousse recipes. Eventually, mine would also show up. So this is not the only application where your content could show up. I'll just give you an example that web search is, for instance, an application that would also show Google-based content. If you're in the US, this currently does not work in Europe. I was told it's a bug. But if you're in the US and you enter this into your web browser, you'll see something like that. So Housing New York is obviously a query where we believe that Google Base has good results. So we show you this small UI here that allows you to do the same thing that you can do also on the attribute search front end, but directly embedded into the web search application. So you could, in this case, we're listing only one attribute, listing type. You could refine it here. You would click go, and what happens is you would go back to the search front end. Here we would list some additional attributes so that you can refine the search even more. We'd also show you a map with locations where the different housing items are pointing to, basically. So as you can see, the UI of this search application depends also on the item type. So for housing, we're showing this map. For recipes, we would probably not show it, would show an image, and that's it. There are other applications exposing Base, and I have a final example. This is, for instance, product search. Product search was formerly known as Frugal, is getting all its content from Base. So all the offers you see here on this page are items in Base. And they are all of the item type products. So if you're uploading a products item, it could show up here. So the message is basically that we have several applications inside of Google built on top of Base, and that the content you upload into Base will show up in the respective application depending on the item type, but also, of course, on the quality of your data. So if you give us, for instance, a product and you're using recipe attributes, we'll not show it, of course. We'll figure out that this is spam and eventually also disprove it. But the second message is that all the content you upload into Base is accessible by anyone. So there's no notion of privacy on the item level. And the last message is that you can also build applications on top of Base by using the API. And this is what I'm going to focus in the last half an hour. So yeah, let's go on. So the Base API gives you programmatic access to content in Base. It is a RESTful API that is based on the GData protocol. And the functionality roughly is that you can use it for querying content in Base, so you can create mashups, for instance. But you can also use it for managing your content in Base. And final functionality is necessary is that it gives you some access to metadata. Because content in Base is so dynamic and so diverse, we need services that allow you to figure out, for instance, what are the attributes that I have to query for. I mentioned already mashups as use cases for the API, but of course we also want to allow people to use that for managing their content. For instance, for giving us content, or for deleting it, managing it, transferring it to other accounts and things like this. The API has 3 different categories of services. First of all, there's like data services. This is exposed via the GData snippets feed. This is the feed you would typically use to query for content. And then there's like a bunch of metadata services. I'm going to explain all those. And finally, there's a feed that is very similar to the snippets feed. It's the items feed. And this is the only authenticated feed. This feed gives you access to your content. And this is the only feed that supports all the 4 different HTTP methods. So this is a feed where you can delete things, insert things, update things, or also query your own content. Let's talk about accessing data in base. So the first service I was just mentioning. As I said, you have to use the snippets feed for that. And since there's so much content in base, you would typically combine this with some query. So here's a way, if you would use an HTTP GET request in combination with that URL, you would do a full text search on 2 terms, Asian and recipes. This is standard GData, a standard GData feature. And we would return you a feed of items that both contain Asian and recipes. So here's an example how such a feed could look like. So every entry in this atom feed corresponds to one item. So on this, it's a bit small. I apologize for that, but the interesting things are usually small details. In this entry here, which corresponds to one item in base, you can see it has this title, Low Fat, No Fat Chinese Cooking. You can see here, this is an attribute called item type. This defines basically the type of that item. It's products. And then there's a bunch of other attributes, product type, ISBN, author, publisher, pages, price, and so on. These are all products attributes, because this is a products item. Now, if my intention was to search for recipes, then obviously this query doesn't work very well, because it gives me back all kinds of stuff which contains Asian and recipes. So I have to send a more specific query. And this is where we could use, for instance, a GData category. I'm not sure if you went to Frank's talk, but he was explaining what categories are. It's kind of tags you can give. And in base, a category corresponds basically to an item type. So if you look at this URL, the dash syntax would basically restrict results to items that are in this recipes category. So since categories are item types, we would only get back results that are in the recipes item type. And in this example here, we would then use Asian as a restrict on the query side. So this is a result we could get back then. It's again the first item that we get back in this query feed is one that is titled Asian beef pot roast recipe. The item type this time is a recipe, in fact. That is good. And then there's like other attributes. These are the typical recipes attributes, cuisine, course, main ingredient, cooking time, and so on. And as you can see here, the cuisine is American. So I was querying for recipes, and I was looking for Asian, but I actually got back an American recipe. So obviously, if you really want to have Asian recipes, we have to somehow constrain our search even more. And this is where structured queries are coming in. This is something that is not defined for GData. This is something that's specific for the base API. So here's an example how such a structured query could look like. So again, we have the URL with the recipes restrict that would only give us recipe items. And then instead of using a full text search query, we're using this BQ parameter, which is a base query, which has a much more expressive structured query language. And I'll quickly explain what that means, and then we go into the details. So that query basically means return items that have a cuisine attribute whose value matches Asian, and that also have a cooking time attribute with a value that is less than 45 minutes. And by doing this, you would basically make sure that the cuisine of that item type is Asian and not Asian matching some random other attribute, for instance, the title in the previous feed. So the syntax for those attribute queries is the following. You define a name, you have an operator and a value, and this would only match items that have an attribute of that name and whose value is basically restricted by that constraint here. So in this case, cooking time, for instance, is an example where the value would have to be between 0 and 45 minutes. 0 is something that is implicit here, but you could also express that easily. So here's the result. What happens if you actually query for that, if you send that query? So again, we have an entry. The first entry in the feed is called Chinese broccoli beef. The item type is again recipes. This time the cuisine attribute is actually in fact Asian. And the next observation we make, oops, there's a second attribute, also called cuisine, and it's Chinese. So this basically shows that attributes are multi-valued. So you can define many cuisine attributes. In this case, the content provider decided to give us two, one more general one, a specific one. And if you would query for cuisine Chinese, this item would also show up. So this is a good example where the content provider was putting some thought into how the structure of his items are looking like. And he's basically making sure that his item will also show up if someone is looking for Chinese recipes. So the message here is basically, if you're using Google Base and you're giving us content, your content should be very specific, should be rich in the structure, and to make sure that other people find what they are searching for. Here's some more details about the query language. So we saw already there's like text queries where you can mention certain terms, and there's attribute queries. This is new and very specific to Google Base. Those attribute queries consist of attribute names and value constraints, and they would only match if there's an attribute of the given type and whose value matches that value constraint. Some of the things are optional, but this is not relevant for that talk here. And then you can use the typical query composition operators you know already from other Google products, also in combination with attribute queries. So you have conjunctions. You can make sure that both queries are matching. You have a disjunction where either one query matches or the other one. Negations where you can make sure that this query does not match at all. And phrases, which are basically making sure that the queries match one after the other. This is only useful if you combine it with text queries. I have a few examples for you to illustrate this a little bit. So a full text query could look like this. You're looking for Asian and recipes, and in addition to that, you also want to make sure that there's at least a beef, a pork, or a lamb, a token somewhere in the item. Then this is a query that uses a phrase. It would basically match chocolate mousse or chocolate cream, just following subsequently next to each other. Here's a few examples of simple structured text queries. So that query would, for instance, match only items that have a cuisine attribute of type text. There's no constraint on the value. This one would, for instance, match all content in base where the language is set to English, where it's not set to English. Or this is a more complicated one. This would match all items that have a course with a mains value, or it's called main course. You can do the same thing for other types. So here's a few number queries. The first one would match only servings attributes that are exactly 4. This is a range. It has to lie between 2 and 6. And here's a bigger example that shows that you can put things all together and create really complex but very specific queries. So just to decode that a little bit, so that query would only look for items that have an item type of valued products. And then in addition to that, I have two possibilities. Either this item contains the term iPod, in which case I'm exacting a price that is less than $150, or it's an other MP3 player, and then I'm only willing to pay at most $100. So this is basically a query that shows that you can combine all these different composition operators, mix full text queries with structured queries as you want. Some other examples for other data types. So far, this is something you could probably also do with the SQL database if you're indexing it somehow. But we have built in some data types that make it very convenient especially for mashups. So for date queries, for instance, you can define a event date range attribute, and you could say that it has to lie in the given period between the 20th of May 2007 and the 25th of May 2007. Or you could say that it's just in May. Well, this one would basically make sure that the end of the event date range is before the 1st of December 2007, and there's even a time you can mention. You can do the same thing with locations. So for instance, that query would match only items that have a location attribute and where the that location is exactly in Castro Street in Mountain View. You could also give us a lat long latitude, longitude, or you could even specify like a center and a radius, and we would basically match all items that have a location attribute which is pointing to a location in that geographic area. Okay, so the next topic I'd like to discuss is the order in which we are returning items. So web search uses a relevance-based ranking scheme. So the question is, what does that mean for these structured queries? Like your cuisine has to contain Asian and the cooking time has to be less than 45 minutes. It's unclear what it means that something with a higher cooking time is probably more relevant than something with a lower cooking time, but it could just be the opposite. So yeah, we were thinking about this for a longer time, and we actually came to the conclusion that there is actually no good relevance-based ranking for structured data like the data we have in base that is as general as that. So, so what we're doing in the API is basically we are allowing you to specify your own ranking function. So you can, along with your query, you can send us a function that maps your item to a rank, and we would return them in the given rank. So this is the first API from Google that actually gives you this capability that you are defining what is more relevant than as compared to what we're doing typically with web search, where we basically decide what's more relevant than others. So for this, we basically have this is an extension of the query language I just showed you. You can, in this language, access, again, the attribute values, and you can mash them together and compute a final result in the end. And this determines the rank, and the higher ranked items are returned first in the feed. That's basically it. Here's an example. This one would basically look at the servings attribute. We give it the value x, and then we would compute the maximum of all the servings attributes. So the problem is here that content in base is multi-valued, as I explained. So a user could actually decide to give us several servings attributes. So you always have to use an aggregation operator in order to map it to a single value. In this case, we're only interested in the maximum. This is a complicated, a slightly bigger example that also considers the fact that it could happen that a content provider decides to not give us a servings attribute. Since you can combine those ranking functions with any arbitrary query expression, it is not guaranteed that there's always a servings attribute. So in this case, this expression would basically make sure for the cooking time attribute that it has to exist first of all, and then you would take the maximum. Otherwise, it says fail. And fail in this context basically means, well, I can't rank it, so it will not appear in the feed in the end. So this is kind of a second way of constraining the result set in your feed. I'll show you an example, some more other examples with other data types. For location, for instance, a common use case is to rank items first that are close to a given location. And this would be achieved by the first expression here. So this ranking function would basically look at the location attribute. It is of type location. They can be the same. And then you would basically compute the distance between the location and that given address. Well, you're in California, somewhere in the city center. And what you get back is a set of distances, because again, a user could mention several locations within an item. And we take the minimum of it and negate it, because we want the smallest location to have the highest rank. So we do this just by negating it. So this function would basically return results by looking at the distance, and the closest results are first. You can also combine several criteria into one, so this is a more complex expression. I'm not going through it now, which mentions two attributes and meshes the things together, and you get back results sorted first by the bedrooms attribute and then by the bathrooms attribute. So if there's a tie between the bedrooms, then the number of bathrooms would basically use as a second criteria. And this is how this looks in the API. So we saw already the gdata restricts. Then there's a query using the PQ parameter. And this new parameter that we just discussed is called order by. that allows you basically to specify that ranking function. Yeah?
Isn't there a problem with the get length restriction? When I see those codes, I think they are getting pretty long.
Yeah, the queries are getting very long. We are not too unhappy, actually, that some browsers have restrictions. Yeah, but you're right. Depending on what tool you're using, you might be restricted. But the HTTP protocol doesn't really put a length restrict there. So Internet Explorer would typically restrict it to 2 kilobytes, something like that. But as I said, I'm not so sure if we are happy about too long URLs. And we have also put in restrictions. So it could happen that if you have a URL that's a couple of K long, then we will basically not accept your request. I don't have the quota in my head now, but there are restrictions. Okay, so let's look at the final topic. It's called crowding, and that's a feature that is very specific, but it's useful actually to use it. Because when you're writing the query application, you will often notice that suddenly there's, for instance, one content provider that is dominating all the search results. You put content into base, and you query for your own content, and it will never show up on top because there's like this other provider that, for some reason, is always first. So this gives you basically a means to introduce a little bit of diversity into your results. And this uses basically the same mechanism like before for specifying the rank. A crowding function is basically a function that maps an item to some string. And you can specify how many items you want that are mapped to the same string. So for instance, if you want that from a certain content provider, you only show up max at most 3 items. You could say, okay, I'm taking the customer ID as a way to identify the customer as my classification mechanism, and then I allow only 3 items per customer. And in the API, this could look like this. You say crowd by, and this is a short form for customer ID that I just mentioned, and you restrict it to 2 in this case. So per content provider, you have at most 2 results in your query, in your feed. And of course, again, like for ranking functions, you can also specify a more complex function. Here, this function, for instance, would make sure that there is at most 1 item per price showing up in your feed. So you won't have like, if you're, say, you're querying for, what do we do? Querying for iPods here, you do not want to see 20 offers that sell the same iPod for $129 or whatever. So this would make sure that you get only 1 back. Okay, so much about data. Let's quickly talk about metadata. And so the problem we now have to solve is, how do you know what attributes you have to query for? Because obviously all those queries require you to know something about the domain. And this is where the metadata services come in. So the first one is the attributes feed. This is very similar to the snippets feed. That's why I can do this very quickly. It has basically the same features, the same parameters. The only difference is that instead of returning actual results, it gives you back an aggregation of the results so that you get an idea of the result space. What aggregation means is, in this case, it's computing histograms for you. So what you get back is a histogram of the most frequent attributes in items matching your query. And then per attribute, you get back the most frequent values that were found in the items that are matching your query. So here's again our query, Asian recipes. This time we're using the attributes feed. And well, if you send this to the API, you will get back a feed of entries. Every entry corresponds to 1 attribute. In this case, item type, obviously, is the most frequent one because every item has to have an item type attribute. And there's like 2 kinds of values that are appearing most. This is recipes and products. There might be some noise, but we are filtering out the noise. It's kind of a spam protection tool. So, if you're sending Asian recipes, you'll get back either recipes or products. And in the example I showed you before, we actually got back products. That's why we had to reformulate the query a little bit. The second most frequent attribute for that query is cuisine. Then there's main ingredient, and then you get some product-related attributes like brand and condition. And with every attribute, you get again, a list of frequent values that content providers are using. So the use cases for this histograms feed is basically that content providers have a means to figure out what kind of attributes other content providers are using. Or they could also use that as a means to say, okay, I want that my item is triggered when a user sends that query. So the content provider could figure out what are the relevant attributes that are necessary so that the match will, so that his items basically will show up in the result set. And of course, this has also use case for application developers, because if you want to develop a UI like our generic search UI that I showed you in the very beginning, which has pull-down menus and for attribute values, this is a way to get the content of those pull-down menus. You could then use that, for instance, for getting the most frequent values of an attribute that you know already. A second way of getting information about item types is the item types feed. As I said, Google proposes a number of item types, mostly item types that we are using in our own application. We describe this by a number of recommended attributes, their type, and sometimes also values. And you can query those basically via that item types feed. This is a pretty static feed. It doesn't really change a lot. Since Google Base is organized in locales, there's not really a lot of them currently. It's basically American English, British English, and German. You could use that basically for getting all the item types that we're proposing for the US. And the feed would look like this. You have the first one, is the most important one for us, is products. And you get all the attributes that we're proposing, housing, all the housing attributes we're proposing, and so on. But as I said, we also want you to define your own custom item types. So if you have data that doesn't fit into the categories I just showed you, then you should really use your own item type. You should give them an own name, and you can use whatever attributes you want us to index. All the content will be put into Base, it will be indexed, you can search for it, but it will in this case not show up in Google applications. Okay, so finally we're coming to the content management part, which is all about giving us content. We have, the features are basically the following. This is basically a typical GData application, so what you can do is you can insert items, you can update them, you can delete them, and you can query for them in your own items, basically. The highlights are basically that whenever you insert something with the API, or you update something, we will do that immediately. So it should take at most a minute or so, and it will be indexed, and you can search it worldwide. Whereas, for instance, the feed system would have a delay of a day or so. Also, delete operations that take effect immediately, and you also get immediate feedback if something is wrong. So if you send us an item which is not well-formed, we'll tell you immediately what's wrong with it. Another feature is reporting. So we keep track of where we are actually showing your content. So if you give us an item, we will count every single impression. We will count every single click on the URL. Of course, only on our property, because we cannot control what other people are doing with the URL they get via the API. And also the page views, because we're generating for every item we're uploading into Base. If it doesn't have a URL, we generate a page for you. So you can basically see how well your item was doing, how many people were accessing it. This is all exposed via our content management functionality. And the last feature is private attributes. I mentioned that all the content you upload into Base is public. But you have the possibility to define some attributes, to label some attributes as private, so they will only show up for you. So this is a way for you to for instance, to associate an item with an entry in your database. There's other applications where you would like to store something that is only of interest to you, where you don't want other people to see it, then you can use private attributes. But they will not show up in the snippets feed. They will only show up in your own items feed. Okay, so this is the feed. It's called items. It's authenticated as opposed to all the other feeds I showed you before, and supports all the 4 HTTP methods that exist. And here's a simple request that would just post a new item to the items feed. You can specify an entry. This would represent your item that you want to insert. You use basically the same schema that you saw before in the feed. You can upload it to us, and it will be searchable once within a minute. of course, you can also query it. You can use the same parameters, Q, BQ. You can use even ranking features or crowding features. One of the things that I didn't explain is a parameter which is sometimes quite useful. It's the content parameter, which determines what the actual content is that is contained in an entry in a query feed. This also works with the snippets feed, but it's most useful for the items feed. So for instance, if you're not interested in the attributes, if you only want to see your statistics, you could mention only stats here, and we would only show you, of course, all the atom components. So you would see the identity of your item, you would see the title, the description, and so on. But we wouldn't show you any other attributes. We would just show you the statistics. And here's an example how this could look like. So this is a result of the previous query, which also contained the attributes. These are all the blue ones. But this red part is basically a part that we only add if you specify that you want to see statistics. So if you add the stats value to the content attribute, you'll get the number of impressions. So in this case, for this item, there were like 56 people were accessing that item. So it was contained in 56 query results, 19 of which were via the API. All the others were on other Google properties. And then there was like 5 clicks on the URL and 5 page views. So this can be basically used for you to see how well your content is doing on base. It's very similar to the way we're tracking ads clicks. And on top of this, you basically have the existing typical attributes of your content, with the exception of that line here, which basically shows an attribute that is labeled as private. So this is something that you would not see in the snippets feed. This is just your content that only shows up in your feed. So, and to finish this, I have one small example how people are actually using this. So Honda decided, for instance, to give us all their content about used Honda cars that are being sold throughout the US. And they upload this into Base every day, and then they have a UI that looks like this, where you can specify a zip code, arrange around this zip code where you're living, basically. Then you can specify a model, a year, make a restriction on the year or the price. And then when you hit search, you get back the results. And this is all done via the Base API. So the query would be translated into a structured Base query, which in this case might be pretty long. And it returns results in a feed, and they're basically displaying it in a UI like this. In addition to that, they're also basically showing a map where you can see the various cars where they are sold. And we have like a collection of many other examples showcasing how people are using the Base API on that URL. And yeah, that was basically all I have to say about the API. If you have questions now, I'm happy to answer them.